membrane fluidity. The membrane of cells is not a fixed, firm thing. It is flexible. It is fluidity. It has fluidity. And these glycolipids and phospholipids in them, they can rotate and even wander to the other side of a cell within just a few minutes. And there's all the time movement. And depending on how much fluidity there is on how much double bonds are in the double fatty acid tails of the phospholipids and glycolipids, and also how much cholesterol is there. And they seldomly flip-flop to the other side, but they stay there like that on the one side of the lipid bilayer, with a non-polar region in the middle. That is why they don't flip over. With glycolipids and phospholipids, they have all, the phospholipids have Phosphor Head, which is polar and hydrophilic, and the glycolipids have a carbon head, which is also hydrophilic and polar, and they all just want to be there to the outside, to the extracellular fluid, the watery part of the outside of the cell, and the other ones on the other side of the lipid bilayer want to go to the cytosol, the fluid part on the inside. In the middle, that is hydrophobic, they don't want water, non-polar, so they're not changing the sides. All these glycolipids and phospholipids. Glycolipids are anyway just on the outside. And they are moving to the side, so it is able to puncture such a cell, they're going to the side and going in again. And that makes it possible to make fertilization, to go in with something and change it, put something in and go out again, or also cloning. Dolly the sheep was able, because you can go in with a needle and exchange the thing in it, to put another one in, and then you can clone. So the things are moving to the side, they're moving and closing in again. And the cholesterol is it which makes the fluidity down. If there's a lot, the cholesterol makes it more firm, but also makes the fluidity down. And by cold-blooded animals, that has an advantage because it works the other way around at low body temperatures. It's not explained how and what, but it could be like that. Cholesterol in a warm-blooded animal like humans, where it makes it more firm and less fluidity. In cold-blooded animals, reptiles, lizards, whatever, snakes, where it makes it more fluid at low body temperatures, as snakes can have. And then if they are in cold mode, they still can have fluid blood, because the cholesterol makes it there at low temperatures more fluid. Not in fixed, not in higher temperatures, where it makes it more firm, less fluidity in humans. And that is why one idea why cholesterol can be a problem, too much of there, excessive, that it might cause atherosclerosis. But cholesterol is bonding with its OH polar head to the polar heads of the phospholipids and glycolipids, and makes it more stiff, less fluidity. And if there's too much of them, it is too less fluidity there, and the cells lining the blood vessels are having not so much fluidity. It's hardening of the arteries or of vessels, atherosclerosis, and that is the idea that too much cholesterol can lead to atherosclerosis. And that is according to Gerard Torres and Senegabowski's Principles of Anatomy and Physiology book on the page 63 and 64, but this is no substitute for medical knowledge, also non-medical.